Hello gentlemen, welcome back. This video is going to finish up complex numbers. We're going to start by talking about complex conjugates. A complex conjugate of a complex number a plus bi is simply changing the sign here from positive to negative. If this was negative, it would become a positive. Okay, so basically what we have, the product of a complex conjugate is the real number a squared plus b squared. In other words, if I had this example, 2 plus 3i, the conjugate is 2 minus 3i. If I want to multiply those together, again, this is just foiling this out. So I'm going to go here, 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 and here. And if we do that, we're going to get 4 minus 6i plus 6i minus 9i squared. Okay? Obviously, these two terms cancel. Remember, again, that wherever we see I squared, we're going to replace that with negative 1. And so that becomes 4 minus 9i squared, or 4 plus 9, which is going to give us the square root of 13. Okay, so complex conjugate, again, I showed you 1 up there, but if I showed you, if I had 2 minus 3i, the conjugate of that is 2 plus 3i. Okay, so I'm just going to take the sign and I'm going to switch it. That's how I find the conjugate. If I have real numbers a, b, c, and d, we're going to look at division now. Let's look at division properties. If I just have, again, a and e are real numbers, I can break this up. You guys understand this is just a regular rule of division. So I can go a over e plus b over e times I. Okay, that's simple division. That's sort of like the scalar multiple rule that we learned before. The more complicated one, well, here's a quick example. 10 plus 4i over 2. I can take each term individually and divide it by 2, which is going to give me 5 minus 2i. Okay? The more complicated situation is this one right here. And again, whenever we have a complex number in the denominator, we want to get rid of that. We want to get a real number down there. And the way to do that is to multiply the numerator and denominator by the conjugate. Okay? So in this particular situation, I've multiplied top and bottom by c minus di. And what that's going to allow us to do on the bottom is I'm just going to get c squared plus d squared. Okay, this is from the last slide here. On the top, we're going to FOIL. These two we're going to FOIL, just like we did before. Okay, and this is what it simplifies down to. But you guys should pause the video and show that a plus bi times c minus di, if I multiply that together, I get what's in the numerator over there. Okay, so you guys should pause and make sure that you understand that part of it. Let's do an example here. I got 5 over 1 minus I got a complex number in the denominator, so I got to get multiply top and bottom by the conjugate. The conjugate here is 1 plus I. On the top, I'm going to get 5 plus 5i, again, just simple multiplication rule. On the bottom, I'm going to get 1 minus I squared, and remember that I squared is negative 1, and so I'm going to get 5 plus 5i over 2, and I can break that up. Here's my real part, and there's my imaginary part. Okay? Do another one here. 6 minus 7i over 1 minus I. Again, we have a complex number in the denominator, so I have to multiply top and bottom by the conjugate, which is 1 plus 2i. And so on the bottom, I'm going to get 1 minus 4i squared. And again, I squared is negative 1. So this bottom here is going to be equal to 5. What I got up at the top here is simply by FOILing these two out. Okay, so if I put parentheses here and here, and I FOIL, that's what I should get. Again, on the bottom, I'm going to get 5, and then I'm going to combine terms. I get 20 plus 5i over 5, which is 4 plus I. Again, pause the video, make sure that you guys are understanding how to do these steps. Here's we're going to have an addition, but before we can add them, we need to have a common denominator. The common denominator here, this is actually a pretty straightforward one. is 2 plus I times 2 minus I. And so what I'm going to do is multiply top and bottom of this first term by 2 minus I, which actually happens to be the conjugate, which makes it nice, and this term by 2 plus I, top and bottom. Okay? If I do that, bottom is 4 minus I squared, so I'm going to have a common denominator here. Again, this is 4I minus 2I squared. Again, I have an I squared term I'm going to write as negative 1. I can combine these two terms. Again, now I have a common denominator of 5. This part right there gets reduced down to this. And this part right there is coming from that term up there. Okay, my common denominator is now 5. Okay, which is 12 plus 9i over 5, or 12 over 5 plus 9 over 5i. This is standard form right here. Okay, the real part and then the imaginary part. I use the quadratic formula. We know the quadratic formula. Quadratic formula, negative b plus or minus square root b squared minus 4ac over 2a. And here I simply plug in. And again, the discriminant here is going to tell me what type of roots I'm going to have. What you should notice here is I got 36 minus 40. So this term right here, the discriminant is going to be less than 0. And because it's less than 0, it tells me I'm going to have two imaginary roots. So we're going to simplify this a little bit. I get negative 6 plus or minus square root of negative 4 over 2. I can bring that out and rewrite that as 2i. Okay, so we've got negative 6 plus or minus 2i over 2. Again, I can simplify by dividing each term individually. Okay. Let's look at simplifying this. I to the 21st power. Whenever I do this, I always want to, if I have an odd power, I want to take an I out and rewrite it like this. Now what I want to do is rewrite this even power as I squared to some power. And again, using my rules of exponents, I know an exponent to an exponent I multiply. Okay? So this is I to the 21st is simplified down to this step right there. I know I squared is negative 1, and negative 1 to an even power here is going to be positive 1, and therefore I'm just going to get I. Try another one. If I simplify this first term, that first term is going to be negative 4, okay, because I have 2I squared. Well, I factored out 2I squared, sorry. 2 minus I. This term right here, I squared, is going to be negative 1. Okay, so I have 2 times negative 1. This is the I squared, this right here. That's I squared. Alright, and then I can distribute through like that, and finally get negative 4 plus 2i. Okay? If I look at this particular term, again, let's get rid of that I. Let's get rid of that negative under the radical, which I can write it like this. I know that I can write square root of 2 is 2 to the 1/2 times I to the 6 like this. Exponent to an exponent, I'm going to distribute, so I've got I cubed. Remember, I want to write I to the 6 as I squared times something, because that's an even power. Okay? I know that I squared is negative 1. I know that negative 1 cubed is equal to negative 1, so my final answer is negative 8. Alright? Here, let's distribute that through. I get 1 over 8 times I cubed. Again, let's break that up into I squared and I. And I squared, I skipped a step here, so let me just write it out for you guys. I have, this is 1 over 8 I squared times I. That term is negative 1. And so I get negative 1 over 8i. Again, I can't have an I in the denominator. So I need to multiply top and bottom by I. I get negative I over 8i squared. Again, I squared is negative 1. That negative and that negative 1 are going to cancel. And I'm just going to get I over 8. Okay? Here's some practice, gentlemen. You know, pretty straightforward stuff. Here's some examples that I want you to pay particular attention to. Here's some problems. But just to review, this was the second part of complex numbers, or complex numbers. We learned about the conjugate of a complex number, and we looked at division by just a real number, and then we looked at division by a complex number, and we looked at how to get rid of the complex number in the denominator, which was simply by multiplying by the conjugate. All right. Any questions? Make sure you guys email me, and have a good day. See you, fellas.